Hey you guys, we are going to look at Chapter 1, Section 3, Algebraic Expressions, Part 2. So in Part 2, we are still looking to evaluate algebraic expressions and simplify them. We're looking to model them and to model sentences. We also have some more vocab. Alright, so starting out with the vocabulary, a term, the word term, that's an expression that is a number, a variable, or the product of a number and one or more variables. So we're going to write number in here and variable. So an example of a term, well, a number, so like 2, or a variable such as x, or the product of a number and one or more variables. So like 3y or 3xy. All of those are considered terms. So here I have 1, 2, 3, 4 terms. All right, a coefficient. Coefficient is the number factor of a term. So, for example, if I have the term 8w, then the coefficient is the 8. It's the number part of that term. Also, if I have the term f, my coefficient here is 1 because I have an invisible 1 right in front of the f. A constant term. A constant term is a term with no variables. Constants don't have variables, they're just numbers. So a constant term would be a number like 3/2, or the number 5, or the number -63. All of those are constant terms. Like terms. Like terms are terms which have the same variable and are raised to the same power. Power is another word for exponent. So if you want to remind yourself, a power is the same thing as an exponent. I'm running out of room. Okay. So an example of like terms. Well, 6x and -5x. Because both of them have an x, and the x's are both raised to a power of 1. We also could say y to the third power and 4y to the third power. Those are also like terms because they both have the variable y and they're both raised to the third power. What I want you to do is go ahead and create an example for each of these. I want an example for a term, a coefficient, a constant term, and like terms. Create your own example. Alright, so let's simplify algebraic expressions. So our first step is to identify like terms. And our step 2 is to combine those like terms by either adding or subtracting. Now before you can actually combine like terms by addition or subtraction, you might have to use some of the properties like distribution. Let's look at our first example. We have 7x squared plus 3y squared plus 2y squared minus 4x squared. Alright, well we can see that our like terms are terms that have the same variable with the same power is 7x squared and 4x squared. Notice though the 4x squared is negative, so that sign that's in front of it goes with it. So when I want to combine these two together, well, it's the same thing as saying 7 minus 4. And I get 3, and their like term is the x squared. Whatever the like term is, just keep that. So their like term's x squared, so I kept it, and I'm just adding or subtracting their coefficients, so 7 minus 4. I also see that these middle terms are like terms. What's alike about them is they both have the y squared, so I'm going to keep that y squared, and I'm going to add their coefficients. So I have a positive 3, a positive 2, so 3 plus 2 gives me a positive 5. X squared and y squared, they have the same exponent, but the variables are different, so this is as far as I can combine them. Or this is as much as I can simplify it. Looking at my last example, I see like terms here. I see a couple of p squares and I see a couple of q's, but I also see parentheses. So before I can combine anything, I need to distribute. So this first p squared, I'm just going to rewrite it. But this positive 3, since it's outside of the parentheses, I'm going to distribute it. The sign matters. If it said minus 3, then I would distribute a negative 3 to both terms. So positive 3 times p squared is a positive 3p squared. Positive 3 times negative q is a negative 3q. And I'm going to bring down the rest of my problem. Minus 5q plus 12q squared. All right, now I want to combine. So looking for variables with the same exponent or powers, I have this p squared and I have a positive 3p squared. Well, I know my coefficient for the p squared is really a 1. So again, keep your like term, p squared, and combine their coefficients. So 1 plus 3 is 4. I also see I have a couple of q's. So I keep that like term of q. I want to write that in blue. Let me erase it. So I keep the like term of q, and I'm going to combine their coefficients again. So I got negative 3, I got a negative 5. So negative 3 minus 5 gives me negative 8. So negative 8q. And then I have this last term up here. It doesn't have any 1 to combine with, so I just bring it down, plus 12q squared. All right, so I'm going to check it one last time, make sure I don't have any other like terms. P squared, a q, and a q squared. I do not, so this is as simplified as I can make this expression. All right, so you guys try these two problems over here. This second one's a little tricky because it has this negative on the outside. Think of that as a negative 1. Negative 1's on the outside. So you're going to have to distribute this negative 1 to both of those terms, just like you'll have to distribute this positive 2 to both of these terms. So go ahead and take a minute and try those two problems. All right, this last slide, it just shows a lot of different properties that you use when you simplify algebraic expressions. Now, most of these you probably already know, like the definition of subtraction. It's just saying that if you are subtracting a minus b, that's equivalent or it's equal to adding a negative. So, for example, it's saying that if you have something like 5 minus 4, that's the same thing. It's equal to 5 plus a negative 4. So I kind of want you to just look through all of these different properties, and I want you to write an example for each one. So how I just wrote an example for the first one where I used numbers instead of letters, I want you to do that same thing. And I just want to make sure that you understand all of these properties, that you understand what this means. It's showing that the left side is equivalent to this right side. All right, and that's it, you guys. So go ahead, make an example for each one. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. I need 9 examples here using numbers instead of variables. And that's it for this video, you guys. So I'll see you in class tomorrow. Thanks.